Hey guys, it's Jair, and today I'm going to be introducing you guys to my new series. This series is going to be walking you guys through the different features of my library called Mint. Now, Mint is a really awesome library that I made about a year ago, and basically it just has general features for every application that you make. So if you're just making a small application, Mint always can help you. If you're making a huge application, Mint can also help you. No matter what kind of application you're making, Mint provides this like so many features that once you start using it, you're never gonna want to not use Mint because it's just so helpful in every single application that I make. I always use Mint, and as a matter of fact, since I did make Mint quite a while ago, around a year and a half ago, I'm actually creating a new library called Guru. You guys have seen this site probably, if you do follow me on Twitter or something like that. And basically this library is just going to be a revamp of Mint. It's basically a better version of Mint, because I did make Mint quite a while ago, as I said, and there's some stuff that I did in there that I just don't like and I would like to replace in this time, and I can't just go in there and just replace it because that'll break people that already have been using Mint. I do have around 200, 300 users, which is absolutely awesome, guys. Thank you for using the Mint platform. It's great that I can just put something open source out there and then you guys can use it over all the other competing libraries like Google Guava. That one's huge, but I still don't like Google Guava. I always prefer Mint. Because there's just some stuff that they did since it was made quite a while ago too. It was made like 2009. There's just stuff that they did that I just don't like. I disagree with. And Google in general, I just disagree with. I don't like Google, even though I'm using YouTube right now. But yeah, never mind about that. Let's get started. Just make some random project. Disconnect from this. All right, let me just make a new package. And we'll make a main class. I picked a random name. Alright, there's our main class. Now let me just add Mint to the source path, jar path, whatever, build path. Alright, now we can use Mint. Refresh for that nice little icon. Okay. Alright, so first thing about Mint is understanding its event system, because the event system is used pretty much everywhere. And it's kind of like the backbone behind everything. The core libraries are there first that you need to know about, and everything uses them. But events like the second module that actually corresponds the entire thing together. So let's start out with creating an event manager. And this is what pretty much you can always do in your applications. You're always going to want an event manager. And usually that event manager type, you're going to want the one that's built into Mint, so you don't have to write your own. It's called Universal Event Manager. As always, I do let you guys write, your own event manager, your own implementation for pretty much everything in Mint, because I do support, say you want some features added or you don't want some features, you can go ahead and just write an implementation yourself. And a lot of times I do actually provide abstract classes that implement, the type and actually help you if you do want to create your own implementation of, whatever service provider that, I'm doing. And also by default with my dependency injection framework, we'll talk about that in other videos. By default, I do set it implemented by the, universal one that I made. So anyway, we'll ignore dependency injection for now, and we're going to just look at what Eclipse tells us about an IntelliSense. So if you just go to the Eclipse IntelliSense type dot, you basically get to see all the methods that you could possibly use. So right away you notice these two specific for Event Manager, Register Listener and Dispatch Event. So the way the system works is you register your listeners and then you dispatch event, and when you dispatch an event, it goes to all applicable listeners. So the first thing we're going to do, we're going to make a listener. So I don't know about you guys, but making a listener is probably the hardest thing you can ever do. You implement event listener, and there you go, you made an event listener. That's how you do it. So let's go ahead and register that. Okay, we got that registered. So now let's make an event. This is also one of the most hardest things you can ever do. You know, it just goes to show how hard this is to use. Make an event. Alright, there's our event. So now we can go ahead and we can manager.dispatch event, new test event. Alright, so let's get to something that's actually difficult and actually you know, makes whatever. So I'm just gonna make this real quick, and you guys can watch and watch in confusion, I guess, as I make it. Alright, so now I got some explaining to do. Alright, so basically there's a contract, and the way that an event system works is you have methods that are annotated with event handler. And the event handler annotation actually describes the contract that you need to follow when you want to subscribe to some event. So you see, it's used to mark as a delegate for the handling of an event dispatch. So what it means pretty much is that, you know, basically it's just saying if you have a method annotated with this, this is a method for handling event dispatches. Okay, so these should always be inside event listeners. You should always be implementing event listener when you have a method annotated with this. So here's the contract. Event handler methods should contain the event type, which in our case test event, that they're expected to handle as a single argument. So you can't have any other arguments. So I'm sorry guys, if you have some like random integer argument second, like how am I supposed to know what to inject in there? I don't. That's why you need a single argument, and that is they should only have one argument, which is the event type they should handle. Basically it's a restate, just in case you guys don't understand. So that's it. There you go. The only other thing is that these methods have to be public. That's the only thing. It could be a Boolean, it could be whatever. You could have any return type. It really doesn't matter, although I don't see how that's useful. But it can be any return type. Just has to be public, and you have to have the event type a single argument and annotate with this. So nice and easy. Once you get used to it, you'll get very used to it. Just put whatever in there, and then when you run it, there you go. Just like magic, it just works. The way it actually works is this is also why my event system, if you guys ever hear a bucket, I did rage at them because they refuse to use my event system over what they have, even though it's pretty much the exact same implementation, but mine's 400 times faster. Over 400 times faster. Because what I'm doing in register listener is I scan the actual, like, you know, event listener class first and say, alright, whatever, I got all these implementations, and then I actually tag along the method name. So when you do like 1,000 dispatches of the same event type, all the stuff is going to be instantaneous. It's not going to be using the reflection each time, except for just to call it, which doesn't actually use reflective NRX, what I don't even know the name, annexations or something like that. I don't know what it's called, but basically you don't have to really use reflection when you're doing it. It just does reflection when you register, which is slow, and it doesn't take seconds to register. I mean, it takes like 100 milliseconds to register or whatever. And then when you dispatch, it's really, really fast. It's pretty much just like calling the method and passing in the type, which is very, very fast. And like I said, so much faster than Bucket's event system. So just a little brag over there, because yeah, it's fast. So let me talk about adding data to an event type. So say I want to just add some random data. I don't know. Call it name. I know there's shortcuts to do this, but I really don't even feel like it because it's just one property. Alright. So there we go. We added some data, and guess what? Since we're passing this, we need to fill it out. Alright, since we're passing the test event type as the argument, you immediately gain all the access to that new data that you added. So we can immediately say, alright, testing get name, and then we run testing Thomas. Change this to whatever, and whatever works. Alright, so now I'm going to talk to you guys about event handler priorities. So say I want to have another event handler and I want to order something, so I'll just call this test 2. Right? So how are you supposed to know what's the order? I mean, if you think about it, So the order that they're going to be registered, the event handler stubs are going to be registered, is it's going to go through them, and then whichever is alphabetically, whatever, it'll do it that way. But what if, like, you can't? There's no really guaranteeing. If you change the method signature, the ordering could change. So you need some way to prioritize these certainly. So what you can do is use event priorities. So say I want this one to run before the other one. I'll set it to high. So let me explain these different priorities. High means it's the first one that gets executed. So in the order of execution, high is always going to be first. Then it's high, then it's normal, which all event types, event handlers are set to by default. Then it's low, then it's lowest, and then it's monitor. Don't worry about monitor for now. Alright, we're going to set this one to highest, which means that one should always execute before number 2. So let's see, it's always executing before number 2. So say we want to just switch this around and we want number 2 to execute first, just put this over here. And when you execute number 2, always gets executed first. Alright, so another way to do it, say we want to reverse the order again, is set this method 2's priority lower than method 1. So we're going to set it to low, and then I see every single time the first testing will run first, and then the second one will run after. So it's very, very useful. So let me talk about how this can be very, very useful. That's what cancelable events. So to make a cancelable event, again, it's very difficult. You just extend cancelable event, and you immediately gain all the cancelable features. So since the first one's getting executed first, let's set that to cancel. Oh yeah, you see the two methods. Is cancel, you could check if it's canceled, and then set cancel. So let's just make it cancel. Oops. And what that's basically gonna, if you think about it logically, this one gets executed first, which means that this one isn't gonna get executed because the event's already canceled. So see, when you run, you only get the first one that executes. But say we went the other way around. In this case, both are going to get executed. This one's going to get executed first. The event's not going to be canceled at the time. And then it's going to do this one, and then that'll cancel further event dispatches. So say we made another one, and we made another event handler, whatever. We made it lowest priority. I'll call it on test 3. This one won't get executed because the second one's setting it to cancel. So you see, same thing. And if we remove the cancellation, we'll see that number 3 does get executed in the proper order. So absolutely great. Now you guys understand that. So I'm just going to go ahead and undo all this stuff. Okay, that seems good for me. Alright, so let's talk about, what else am I going to talk about? Oh, I actually think that's it. So there you go. That's the event system in a nutshell. Very, very easy to use. That's pretty much it. Yep, that's it. Well, thank you guys for watching. Do subscribe, do whatever, and follow me on Twitter. Add me on Facebook. Do whatever. I'll see you guys.